1.10. So if any number is behind decimal point, something like this, if any number is given like this 1.19, you must spell this as separate numbers 1.19, 1.190, and you must not spell like 1.190. If you spell like 1.190, that is wrong. So welcome to your lecture 1.10, and this is the final lecture of laws of motion topic. In this lecture we will be discussing about weightlessness, what is weightlessness and how it is going to be applied, and then we will be discussing about weightlessness of the astronauts, and here you will be knowing that why astronauts are not actually floating but they are freely falling. And then after that we will do application of Newton's law of gravitation. There is nothing much to explain here. I'll be just reading the lines just once for you alone. No explanation will be done here. And after that the lesson is over. Okay. In last lecture we saw about what is the difference between mass and weight. Mass is just a physical quantity which measures how much matter is present in your body. And what is weight? Weight is just the gravitational force of earth or any planets. Mass as a unit is kg and weight as a unit is Newton. And that's all about mass and weight. Okay, then here they gave what is the gravitational acceleration of moon, that is 1.625. That's all. Then apparent weight. Apparent weight definition is here. Apparent weight is the weight of the body acquired due to the action of gravity and other external forces acting on the body. So if they ask write the definition of apparent weight, then if you write this line you will be getting the marks. And later I taught you this box in very detailed manner. This is a very useful box, and in 11th and 12th you'll be recognizing how much important is this in physics. By using this alone, this tabular column alone, they are asking questions in NEET. So if you know this very well, you can attempt any questions in NEET if it comes from this topic. Underline that word, if it comes from this topic alone. And I explained it clearly in Tamil, so I guess there is no more further explanation needed for this topic. And then we are starting with the today's lecture, weightlessness. So if I just say what is weightlessness, then you must be thinking that weight is zero. So weight must be zero, mass must not be zero, because they gave weightlessness. Weight is equal to zero means mass into gravity must be zero. Mass and acceleration must be zero. So how come mass and acceleration must be zero? You might be thinking. There is further things we need to look at here. First of all, let us read the lines. Have you gone to an amusement park and taken a ride in a roller coaster or in a giant wheel? During the fast downward and upward movement, how did you feel? It's just a question. And example, in MGM there is that rainbow ride, and then a blue roller coaster ride is also there, which these two things you can take it as an example and you can continue with it. Then okay, this is the picture of the roller coaster. It's amazing, right? Yeah, it's amazing because adrenaline is being secreted in your blood and you get really thrilled enough. You will be over thrilled. That's exciting. That's what we need. We enjoy it. And why that thrill is coming? It's coming because of apparent weightlessness, and it's ultimately physics. You actually feel as if you are falling freely without having any weight. So there is no weight. Okay, wait a minute. What is weight? First of all, you must be confused now. So here they are mentioning weight as R, a reaction force. So in lift is at rest, or I guess case 4, yeah, falling down freely. This is the case they are going to explain in weightlessness topic. So here R is equal to 0, right? And this is what they are calling as weight is equal to 0. but actually reaction force is measured by weighing machine, and here they took it as weight. There is no much difference, it's a bit same. Okay, when you move down with a certain, okay, fine. This is due to the phenomenon of weightlessness. So what is actually weightlessness? R is equal to 0, or a freely falling condition is called as weightlessness. There will be no external other forces acting, only gravitational force will be acting on you when you are going to fall. What I mean is that, take this as a building and you are going to drop a ball from here. Just just you are going to drop a ball and there is no force you are going to act giving on it. You are just dropping it. So this ball is actually going to meet the ground due to gravitational force. So we can say that this ball, I mean, I'm sorry, this ball is falling freely, and it have only gravitational force which is acting and which is pulling towards its surface, and the ball is actually in weightlessness condition. Are you getting that? What do you mean by weightlessness? This is the overview of weightlessness, and if you have got any doubts, comment it. Okay, sometimes you experience the same feel while traveling in a lift. Yeah, for this box I totally explained everything with the lift. So I also said in I guess that I might have said, okay, let it be anything. In Anegan movie, uh, while the hero and heroine are working in the IT office, they will be met with an lift accident. So they, when the lift is going to hit the ground, the hero, I mean Dhanush, will say to the heroine that jump. You know why he said jump? Because when the lift is going down in free fall condition and they will be also going in free fall condition, so if they jump, they will be seem to be floating, and there will be less hit after the lift is going to hit. அதாவது அந்த லிஃப்ட்டு கீழே போயிட்டு ஃபஸ்ட்டு இடிக்கிறதுக்கு முன்னாடி, ஐ மீன் அவங்க குதிச்சிட்டாங்கன்னா அந்த லிஃப்ட்டு தான் ஃபஸ்ட்டு போயிட்டு ஹிட் ஆகும். ஸோ அவங்களுக்கு டேமேஜ் அதிகமாகாது அண்ட் ரிலாக்ஸேஷன் டைம் அதிகமாகும். அதனால தான் அவங்க ஜம்ப் அப்படின்னு சொல்கிறான். ஸோ அங்கே இந்த ஜம்ப் ஆகிறப்ப அவன் நம்மளுக்கு ஃப்ளோட் ஆகிற மாதிரி தெரியும். ஒய்? பிகாஸ் கேமரா, லிஃப்ட்டு அண்டு அந்த ஹீரோ ஹீரோயின் எல்லாருமே ஃப்ரீ ஃபால் கண்டிஷனில் இருக்காங்க. அதனால தான் அவங்க அந்த 2 பேரும் நம்மளுக்கு ஃப்ளோட் ஆகிற மாதிரி தெரிவாங்க கொஞ்சம் நேரம். ஆக்சுவலி அதில் கொஞ்சம் ஸ்லோ மோஷனும் இருக்கும், பட் டோன்ட் கேர் அபவுட் த ஸ்லோ மோஷன். தே வில் பி ஆக்சுவலி ஃப்ளோட்டிங். I mean weightlessness condition will be prevailing there. Then when the person in a lift moves down with an acceleration a equal to the acceleration due to gravity. So what they are saying is that if the lift is going to move downwards with an acceleration a, and which must be equal to acceleration due to gravity, then that condition is called as free fall condition. I mean the case 4 condition is called as free fall. They are saying that's all. Okay, a is equal to g, that's what they are saying. Here the apparent weight r, that is apparent weight is r, we know that, is equal to m into g minus g, which is equal to 0. So the apparent weight is 0, and this condition is called as weightlessness. So state refers to the state of weightlessness. Okay, this paragraph is totally definition paragraph, you must remember that. The same effect takes place while falling freely in a roller coaster ride or in a swing or in a vertical giant wheel. Giant wheel is nothing but ரங்கராட்னம், பெரிய ரங்கராட்னம். தமிழ் கொஞ்சம் ஒரு மாதிரி தான் இருக்கும், ஸோ டோன்ட் வரி அபவுட் தட். English will be better. You feel an apparent weight loss and weight gain when you are moving up and down in such rides. So there is nothing to explain in this paragraph, because they are saying that you will be feeling something, that you are going to gain some weight if the lift is going up, and you are going to feel that you are losing some weight when the lift is coming down. That's due to these two cases which I explained in last lecture. If you can't get that, then kindly watch the last lecture 1.9 and then come back to this lecture. That's the topic of weightlessness, and we are entering the next topic, weightlessness of the astronauts. So everyone must be more interested in learning about astronauts, space, sun, star, everything. But if you want to learn these things, you must join in some space researching institutes like IISR, which is located in I guess Karnataka or Bangalore, I don't know, somewhere there. And if you join there and you start thinking that physics is over and we are going to learn only space related things, just forget that. Physics is everywhere, and if you want to learn about space, physics is a necessary subject. Everything in physics will be related to space. You can't separate physics and space. You need everything there. Okay. Weightlessness of the astronauts. Fine. Some of us believe that the astronauts in the orbiting space station do not experience any gravitational force of the earth, so they float, but this is absolutely wrong. Yeah, this is a misconception which is done almost by every student. When I am studying 10th, I also thought that yeah, they are floating because there is zero gravity, and actually in Tom and Jerry also they will say that the gravity is zero and we need to provide anti-gravity to stand there, but artificial gravity to stand there, I'm sorry. So there is nothing that the gravity is zero or there is no gravitational force by earth on them. It's not that. It's the case something like this. See, consider this is our planet earth, and no, this diagram will not be enough. Okay, consider this as our planet earth surface, and we are going to stay here. I mean, இங்கேருந்து நம்ம கீழே விழ போகிறோம் அவ்வளோதான். ஸோ இங்கேருந்து நம்ம கீழே விழுறப்ப we will be having some velocity, and acceleration due to gravity g, because we are going to fall freely. That's what the case. There is no external forces, and with us we are going to take another ball, and we are going to just leave it in mid space. So this will also have same acceleration, right? Because this is also in free fall condition. So if you just see this ball with your eyes, you feel that the ball is not falling down. I mean, it's not going below you. Like if you stand, இது நீங்கள் நார்மலாக கீழே நின்றுட்டு, ஐ மீன் தரையில் நின்றுட்டு ஒரு பால் எப்படி கீழே போட்டிங்கன்னா அந்த பால் கீழே போய் விழுந்துடும். பட் இந்த மிட் ஏரில் இருக்கிறப்ப நீங்களும் அந்த பாலை சேர்ந்து கீழே விடுறப்ப அந்த பால் வந்து உங்களுக்கு ஃப்ளோட் ஆகிற மாதிரி தான் தெரியும். ஏன்னா நீங்கள் ரெண்டு பேருமே ஒரு ஃப்ரீ ஃபாலில் இருக்கீங்க. எப்படி சொல்லலான்னா, இப்போ நீங்களும் அந்த சேம் பால், யூ டேக் ஃபுட்பால், யூ டேக் பேஸ்கெட் பால், லெட் இட் பி எனி பால், and I am taking football. If you are going to take your football and keep it in your bus, and you are going to sit in the bus, and the bus starts moving, and in that you might, if you see that ball, அந்த பால் நீங்கள் பார்த்தீங்கன்னா அந்த பால் உங்களுக்கு ரெஸ்ட்டில் தான் தெரியும். பட் அதே கேஸில் நீங்கள் பாலை வச்சுட்டு பஸ்ஸை விட்டு வெளில இறங்கிட்டு அந்த பஸ் மூவ் ஆகிறப்ப பார்த்தீங்கன்னா பால் வந்து மூவ் ஆகிற மாதிரி உங்களுக்கு தெரியும். இதுதான் அந்த கண்டிஷன், வெயிட்லெஸ்னஸ்னு சொல்லுவாங்க. நீங்கள் எந்த இடத்துல நின்று பார்க்குறீங்களோ அந்த இடத்து வழியாக தான் உங்களுக்கு வெயிட்லெஸ்னஸ், ஃப்ளோட்டிங், பால் ட்ராப் ஆகிறது அதெல்லாம் தெரியும். நீங்கள் அந்த பால் கூடயே ட்ராவல் ஆகுறப்ப அந்த பால் உங்களுக்கு ஃப்ளோட் ஆகிற மாதிரி தெரியும். ஒய்? ஏன்னா ரெண்டு பேருக்குமே ஆக்சிலரேஷன் வந்து ஸ்மால் ஜி தான். ஆக்சிலரேஷன் டியூ டு கிராவிட்டி தான், விச் இஸ் ஈக்குவல் டு 9.8 சம்திங், 9.8 மீட்டர் பர் செகண்ட் ஸ்கொயர். இதுதான். So you got this topic right. The same will be here also in astronaut also. Astronauts are not floating but falling freely, like the ball which I explained now, freely around the earth due to their okay fine, around the earth. We stop it over here. What I want to say is that the space station is always rotating our earth in this direction. See, consider this as our planet earth, okay, and this is a space station, I mean satellite or something like that, and here is that astronaut. So what they are saying in this paragraph is that earth due to their huge orbit, okay fine, astronauts are not floating but falling freely around the earth due to their huge orbital velocity. Since space station and astronauts have equal acceleration, they are under free fall condition. I mean, if the satellite is here and the astronaut is here, and here will be the camera, right? See, if you let anything in space, if you throw anything in space with a velocity of 12.4 km per second or something like that with an escape velocity, then it will go away from our earth, because that's the minimum velocity which is needed to get away from our earth gravitational force. But these satellites are not made in that way. ஐ மீன் அதை ஒரு குறிப்பிட்ட இடத்துல அட்மாஸ்ஃபியரில் லீவ் பண்ணிடுவாங்க. ஸோ அதை அட்மாஸ்ஃபியரில் லீவ் பண்ணுறப்ப பூமியை நோக்கி வந்துக்கிட்டு இருக்கோம். பட் ஆக்சுவலாக மேக்னெட்டிக் ஃபோர்ஸு, மேக்னெட்டிக் ஃபீல்ட்ஸு, அப்புறம் ஃப்ரிக்ஷன், ஏர், அது இது இருக்கிறதுனால அது வந்து ஸ்ட்ரெயிட்டாக வந்து விழுந்துடாது. ஆக்சுவலாக அது ஒரு சர்க்குலர் பாத்தில் வந்து விழும். இப்போ இது ஒரு பில்டிங்னு நீங்கள் எடுத்துக்கிட்டிங்கன்னா இது வந்து ஃப்ளோரு. ஸோ இங்கேருந்து நீங்கள் ஒரு பாலை விட்டுறீங்கன்னா அது இப்படி ட்ராவல் ஆகி ஒரு ஹாஃப் சர்க்கிள், ஒரு குவார்ட்டர் சர்க்கிளில் வந்து இங்கே லேண்ட் ஆகும். பட் அதுவே நீங்கள் எர்த்து சைஸ், அதாவது திஸ் இஸ் சக்கிங் அ லாட். So if you take this as our earth and this is the tower, and if you are going to throw the ball from this side, நீங்கள் லைட்டாக த்ரோ பண்ணிங்கன்னா இங்கே விழும். ஸோ லைட்டாக இன்னும் ஃபோர்ஸாக த்ரோ பண்ணிங்கன்னா இங்கே விழும், இன்னும் ஃபோர்ஸாக த்ரோ பண்ணிங்கன்னா இங்கே விழும். அதுவே இன்னும் ஃபோர்ஸாக த்ரோ பண்ணிங்கன்னா அது வந்து எர்த்தோட அந்த சர்ஃபேஸை டச் பண்ணாமல் அது வந்து ஒரு சர்க்கிள் மேக் பண்ணி திரும்பவும் உங்ககிட்ட வந்துடும். ஸோ ஆக்சுவலாக இதே தான் திரும்ப 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 நடக்கும். ஸோ அந்த பாயிண்டில் தான் நம்மளோட சயின்டிஸ்ட்லாம் கரெக்டாக மேத்தமெட்டிக்ஸ் யூஸ் பண்ணி, ஃபிசிக்ஸ் யூஸ் பண்ணி சேட்டிலைட்ஸை விட்டுருவாங்க. அப்படி விட்டுறதுனால சேட்டிலைட்ஸ் வந்து ரொட்டேட் ஆகிறப்ப எர்த்தோட சர்ஃபேஸை டச் பண்ணாது. ஸோ இங்கே லீவ் பண்ணுறாங்கன்னா அது இப்படியே சுற்றிக்கிட்டே தான் இருக்கும். அண்ட் அதுக்கு தேவைப்படுறது தான் ஆர்பிட்டால் வெலாசிட்டி. இந்த ஆர்பிட்டால் வெலாசிட்டி இல்லைன்னா சேட்டிலைட் வந்து எர்த்தோட சர்ஃபேஸில் ஹிட் ஆகிடும். ஸோ டியூ டு தட் ஹியூஜ் ஆர்பிட்டால் வெலாசிட்டி, this satellite or space station is continuously rotating or revolving our earth without any disturbance. And since this astronaut is also with that satellite and he is also rotating with that same orbital velocity, I mean that if the satellite is rotating with revolving with 11.2 km per second, then the astronaut will also rotate or revolve with 11.2 km per second. Whatever speed as the satellite moves, the same speed the astronaut will also move and the camera will also move. So அந்த மூணு பேருமே அந்த மூணு திங்ஸுமே ஒரே ஸ்பீடில் மூவ் ஆகுறதுனால, ஒரு ஆக்சிலரேஷன் இருக்கிறதுனால நமக்கு, அதாவது அந்த கேமராவுக்கு வித் ரெஸ்பெக்ட் டு தட் சேட்டிலைட் அந்த ஆஸ்ட்ரோனாட் ஃப்ளோட் ஆகுற மாதிரி தெரியும். ஆனால் ஆக்சுவலாக அந்த ஆஸ்ட்ரோனாட்டு, சேட்டிலைட்டு, கேமரா மூணுமே கீழே விழுந்துட்டுருக்கு. பட் ஹியூஜ் ஆர்பிட்டால் வெலாசிட்டி இருக்கிறதுனால அவங்க கீழே விழாமல் எர்த்தை ரெவால்வ் பண்ணிக்கிட்டே இருக்காங்க. தட்ஸ் த கேஸ் பிட்வீன் weightlessness of the astronauts. So after I'm explaining this, you must start thinking that astronauts are not floating in space. They are moving with a huge orbital velocity, and that causes floating phenomenon. Just floating phenomenon. They are not floating. It's just floating phenomenon. Like inertia is a phenomenon, weightlessness is also a phenomenon. Hence both the astronauts and the space station are in the state of weightlessness. That's it. That's the end of weightlessness topic. And if you can't understand better, or if you think that you need more understanding, then don't do over things and all. You need to mug up this definition alone. If you just mug up this definition, that's enough for your examination. And if you need to overthink, then just complete SSLC exam, and after that you will be getting 3 months or 2 months leave, and in that leave start thinking, and in 11th and 12th you will be further knowing many other things in gravitation, in laws of motion, Newton's laws of motion. So in 11th and 12th start thinking deeper and deeper. Ask questions to your teacher, ask questions to your principal, to anybody, start asking questions. But in 10th just learn what you are supposed to do. Okay, now the last topic of this lesson, application of Newton's law of gravitation. Very simple, you must mug this up. There is no way. Dimension of the heavenly bodies can be measured using the gravitation law. So what is gravitation law? Force, gravitational force is equal to capital G into m1 into m2 by distance between them, the whole square. This is that law. And mass of the earth, radius of the earth, acceleration due to gravity can be calculated with a higher accuracy. I guess that we got a topic to find mass of the earth. Here I might be seeing here. Wait a minute. Yeah, here we calculated mass of the earth by using gravitational law, right? And everything we can find with accuracy. Accuracy means, okay, you know what is accuracy. I don't want to explain more. Second point, helps in discovering new stars and planets. So how they are doing that is totally a space related matter, and ISRO, NASA things, so we don't need to dig this more. Then one of the irregularities in the motion of stars is called as wobble. I don't know about this, and lead to the disturbance in the motion of a planet nearby. In this condition, the mass of the star can be calculated using the law of gravitation. So if you need to remember this point, just take the example of Pluto. Pluto is not actually revolving in its own orbit, it is being disturbed by another near star. So if you know this thing, then you can know third point. Just this is an example I'm saying. You must not write this Pluto example in your third point. That's very wrong. And you need to highlight this word wobble. Just learn this word wobble. Then helps to explain germination of roots is due to the property of geotropism. Geotropism means uh, the root is going downwards the earth, it is going towards the earth, downward, and that is called as geotropism, which is the property of a root responding to the gravity. So if you keep any plant or any tree which is in an upright position, then you won't see that the root is going to grow in upward direction. It will automatically bend and go downwards because gravity is pulling the roots downwards. But actually the shoot portion, that is the leaves and the other parts, flowers, are going in upward direction, and that is called as negative geotropism, which is going opposite to geotropism. So that's called as negative geotropism, and roots are positively geotropism. Next, fifth point and final point of this lecture, helps to predict the path of the astronomical bodies, and this thing will be explained with correlation with Kepler's laws. There are three Kepler's laws, and if you know that, we can better explain this point. That's the end of the chapter, laws of motion. It's a big way, a 10 videos, a long videos, but I can have completed this. This is my first step towards teaching. So kindly upvote it, like it, share it, subscribe it, and comment it. Whatever you do, just keep motivating me. Thank you. Bye bye.